Hi. In this tutorial, we're going to learn how to move lead-ins, add bridges or tabs, and add screw-down points. These processes are very important when it comes to reducing movement while cutting. We'll start with the flange that we created in tutorial number 5. First, we'll move the lead-ins. This is very simple to do. Go to the Toolpath toolbar and click Edit Star Points. You'll notice markers appear at the beginning of each path. Simply click and drag a lead-in to any position you like. Here's a really important tip you'll want to remember and use. Place the external lead-ins so that the last cut separates the part from the bulk of the material. As an example, this part is located near the bottom left corner of the sheet. Because we chose climb milling as the cut direction when we created the tool path, the outside path is cutting clockwise around the part. You can see this by the way the lead-in enters the tool path. That makes it fairly obvious that the last cut on this shape will be directly before the lead-in. If I want to cut parts from left to right across the sheet, then the bulk of the material will be to the right of the part as it cuts. By placing the lead-in at the bottom right corner, the cutter will remove the scrap at the bottom first, then up the left side, then across the top, and the last cut will be the right-hand side. This means the part stays connected to the bulk of the material right up until the very last cut. That dramatically improves stability during cutting and may reduce the need for bridges or hold-down screws. There's no single lead-in direction that is always best. It depends on the cut direction and where the part sits on the sheet. Just remember, you want the final cut to be on the side of the part with the most surrounding material. This is especially critical with plasma cutting because the metal can distort rapidly, particularly when cutting near the edge of the sheet. Also note, plasma and laser tool paths always cut in the climb direction, which means external cuts will always be clockwise around parts. Next, let's look at adding tabs or bridges. These are small sections of material that are left connected between the part and the sheet. On the Toolpath toolbar, select the Bridges tool. You'll be asked to set the bridge parameters. These settings will be remembered next time you use the function. First, at the bottom, select the bridge style. If you're plasma or laser cutting, choose the 2D bridge style. This creates a small gap in the toolpath, leaving the material connected. If you're routing or milling, choose 3D bridges. With 3D bridges, you can set the ramp angle up and over the bridge, and also the amount of material left at the bottom of the cut. You can adjust the bridge length for both 2D and 3D bridges. Once you're happy with the parameters, click OK. Now you're in bridge mode, and the cursor should look like a small bridge. Clicking on any toolpath will add a bridge using the parameters you selected. You'll see a thicker red line showing the location of the bridge. To remove a bridge, right-click on it and select Remove Bridge. You can also adjust the parameters of an individual bridge by right-clicking it and selecting Edit Bridge. This allows you to change settings for that bridge only. You can also move a bridge. While you're in bridge mode, hover over the bridge and you'll see a dot at each end. Click and drag the bridge along the toolpath to a suitable position. Normally, bridges work best if they connect the part to a screw-down point, or if they line up with a matching bridge on an adjacent part. Right-click and select Cancel to exit the bridges function. I'm going to use the Ctrl+Z undo function so we can demonstrate the next feature. To do that, I'm first going to make a grid of 4 flanges. I'll select the original flange, then go to the Transform toolbar and select Array Copy. I'm going to specify a gap between the copies rather than an offset distance. Next, I'll enter 15 millimeters in both the X and Y directions. Then I'll choose 2 columns across and 2 rows high. Clicking OK will create an array of flanges with the correct gap between the parts. A very useful feature that has recently been added to ToolShop is the Line of Bridges function. This works similarly to the standard Bridges tool, but it's great for quickly adding lots of bridges, and it's also great for aligning bridges between adjacent parts. Activate the function, make sure the bridge parameters are correct, click OK. Then click and drag a line across the screen. Wherever the line crosses a tool path, it will add a bridge. If you drag the line across the gap between 2 parts, both parts will receive a bridge in aligned positions. Right-click and select Cancel to exit the function. A special feature of ToolShop is that if you regenerate the toolpath, it will recreate the bridges in the same locations, even though it is a completely new toolpath. To demonstrate this, I'll make sure the toolpath is selected. Then click Edit Toolpath on the Toolpath toolbar. For this exercise, I'll adjust the feed rate and regenerate the toolpath. You'll see the bridges have been re-added to the new toolpath in the same locations. Lastly, we'll add some screw-down holes between the parts. This is very useful for routing because parts can vibrate and move during cutting. Screw-down points don't apply to plasma or laser cutting. Select the Drill/Pierce function on the toolpath toolbar. This is similar to the Offset Toolpath dialog we used in tutorial number 7. For this purpose, I'm going to use the default template for the 3mm drill. I need to adjust the depth to go at least 3mm, or about 1/8 of an inch, below the bottom of the material to account for the drill tip. I'll also set the Z-feed rate and RPM to suitable values. There are settings for peck drilling as well, but I'm going to ignore those for the moment. If I had circle selected, I could click OK and it would place a drill point in the center of each circle. However, I want to manually place drill points around my parts without drawing circles first. So I'll click Place Drill Points and use the mouse to place as many as I like around parts and even inside holes to stop scrap from spinning or jamming against the cutter. When you have enough drill points, you can right-click and cancel out of the function. So, in this short tutorial, we've covered moving lead-ins, adding and editing bridges, array copying, and the line of bridges tool. We've also learned how the direction of cut affects lead-in placement. I hope this has been useful.